Hi, good evening to all. Am I audible?
Yes, sir.
Okay. Okay. So today we'll discuss the program on the singly linked list. Okay. So before that, I want to show you the question. Yeah, this one. So design, develop and implement a menu-driven program in C for the following operations on singly linked list of student data with the fields USN, name, program, semester and then phone number. Okay. So you need to store in one node, you need to store all this data, and this is the data related to a particular student. So create SSL of n student data by using front insertion. Okay, so you should do the front insertion also. Display the status of SSL, SLL, that is singly linked list, and also count the number of nodes in it. Okay, any point of time you should go for displaying what is the current status of the singly linked list, and it should also tell how many nodes are there or how many students data is present inside the singly linked list. So and then perform insertion or deletion at the end of singly linked list. Okay, so the third option you should have for inserting at the rear end of the singly linked list, and also to delete from the rear end of the singly linked list. And fourth option, perform insertion or deletion at the front end of SSL. So if you are performing the insertion and deletion from the front end of the singly linked list, it is nothing but what the stack, because both you are performing at the same end. So the demonstration of stack, and finally exit. So these are all the things what you have to implement in the singly linked list, and we are going to understand a program for the same now. Okay, so this program USN, name, program is nothing but the department. You can take department, semester and then phone number. So these are the information that's need to be stored in a node related to a particular student. Now okay, this has stopped working. Let me open here. I have the program here, because using this I can also go for writing it. Okay, I can write and show you very clearly. Or else I have it in my notepad also. Okay, I think compared to this looks better. I hope all of you can see this.
Yes, sir.
Yeah. As I was explaining in the yesterday's class, okay. So these are the header files that are included. So malloc.h we are including, string.h, stdlib.h, and then we are defining a macro with the name max and initializing it to 30. And then we are defining one more macro with the name malloc, and these are the arguments which are passing to it. These are the arguments that are being passed to the malloc function. Yesterday I mentioned. So whenever I want to create a new node, so I would be calling this macro. And yesterday I also told you what is the difference between a function and a macro. So function leads to the function call. Okay. So the control just jumps to the function definition, and the function definition gets executed. And whenever you make a call to the macro, so the entire macro gets substituted, inline substitution it is. And I also told you with macro, whenever you are using macro, the program length increases, and that is the disadvantage. Whenever you are calling a function, so it is slower, that is the disadvantage with respect to the functions. But the program length will be very small in case of functions, but program length increases in case of macros, and that is the disadvantage. And macros are much faster than compared to the function call. Okay. Now malloc I've written here. So pst, and I'm calling the malloc function here. So yes is a parameter. We'll just understand this from where we are calling the malloc. So that part we will understand. Yeah, see, when you call insert front, I'll just go to insert front. Yeah, so inside insert front function, you're calling malloc. Okay, what you're passing is q and size of struct list, and then node. Okay, size of struct list structure you observe here. This is the list structure. So I have created a structure with the name list, and I have all the members. So I want to store USN, name of the student, branch of the student, semester, and then the phone number. So I've created. So except this USN and semester, USN also I've taken it as integer. So if you want to store it as the sequence of 10 characters what you have, so then you can go for making this USN also as character array. So right now I don't want to make it as a character array, so one integer number is sufficient for me. I have taken USN as integer, name as character array, branch as character array with the name branch, and semester again as integer, and then the phone number as again character, because phone number you got to enter multiple characters. Okay, so multiple digits. So phone number max, and then one link should be there because every node should point to the next node. So I'm taking a self-referential link, okay, pointer. So struct list. So this star link is of type what? Struct list. That means it points to itself. Okay, and then so I'm creating a type definition to this structure. What is it? Struct list star node. Say for example, if I want to declare a pointer to this structure now, so I don't have to do it struct list and then create star A or star B or star C. So I don't have to do like that. I can just go for using this node. If I say A, A acts as a pointer to this list. Okay, people understood till here? See, if this statement I'm not writing, if I'm not writing this, in case if I want to declare a pointer A to this structure, so how to do it? Struct list star A. I have to do it like this. Now what I've done, I've taken an alias name to my structure. This entire struct list, so I've given an alias name, star node. Now if I want to declare A as a pointer to my structure, so then I can just do it like this, node A. So just by doing this, so and this is now exactly same as what? This. Okay. So now it's easy. Say I want to create a new node, I just say node A. I want to create a pointer to this, I just say node A. I want to create one more node, I just say node B, something like this. Okay, one more pointer to this, node B. So understood? Hope you people understood? Now this node is representing this what? Struct list star. Hope you people understood? Hello, am I audible?
Yes, sir.
Okay. I'm erasing this. Okay, this is what the struct list. Now when I say size of here, inside the, when I'm calling the macro, I'll just go here. Yeah. Size of struct list, what it will do, it will find the size of all these things. So the number of bytes required to store integer, and name max we have defined it as 30. So integer is 2 bytes plus this 30 plus this is 30 again, this is 2 byte, 2 plus 30 plus 30 plus 2 and plus 30 again. Okay, and then this is a pointer again which holds the address, correct, right? So again this is of type integer. Okay, so sum of all these things, that is the amount of bytes required in order to store one node. Okay, that is what is getting computed here. Size of is a built-in function which will find the size of the structure, entire structure. So I'm calling here, see, node Q. Now as already earlier I wrote it as node A. Now I'm writing it as node Q. What does it mean? Q is a pointer to my structure. Okay, I've created a pointer to my structure Q. I'm passing that. I'm passing the size of the struct list, and I'm passing the node also. Okay, now we'll go to the malloc function, malloc macro. So it comes here, and Q, what I have passed, get copied to P. Okay, and size of the structure gets copied to S, and T is the node. Now what I'm doing now, P is equal to malloc of S. So I want to allocate so many bytes of memory. Where is that byte stored? How many bytes of memory should be allocated? It is stored in S, because the parameter which I'm passing to this S is what? Size of struct list. So the total number of bytes required is here, and I'm saying malloc S, allocate so many bytes of memory and cast it to what? It should be of type node now. Okay, and the node is copied to what? T. And what malloc, it allocates so many bytes of memory, and then address of the starting byte is returned to what? P, and P is already made as a pointer to my struct list. I'm just checking here if P is equal to null, so insufficient memory and nothing, the memory is not allocated, and just say exit. Following? So this is important. If you have not understood anything here, so if you have not understood something here, please let me know. I'll clarify. Hello? So I need your response.
Sir, why are we making use of it?
Please.
Why are we making use of malloc function?
To allocate the memory. See, this is using dynamic memory allocation. See, so this is how many bytes required? 2 bytes. So this is how many bytes? Name of max. What is the value of max? We have defined 30. Can you see my screen?
Yes, sir.
Yeah. So for this 30, and for this again 30. So because branch of 30, and this is again 2 bytes, and this is 30, and this is a pointer which stores the address. Address cannot be float. Address is always an integer. So 2 bytes. So sum all these things. 2 plus 30, 32, 32 plus 30, 62, 62 plus 2, 64, 64 plus 30, how much it is? 94, 94 plus 2, 96. Okay, totally one node is nothing but how many bytes of memory?
96.
96 bytes of memory. Understood? So to store the details of one student, how many bytes are required? 96 bytes are required. And I'm
Then we
allocating.
know the byte limit. Like we already know we need 96 byte.
How many?
We already know how many bytes are required.
Correct. That's what I'm doing here. See what we are doing here in malloc. See, instead of I wrote it 2, 30, 32 and then 30 and then again 2 and I summed all these things. You don't have to do that. Size of struct listify. I'm passing this entire structure to argument as argument to size of function. So this size of function will compute it. Correct, no? Now the size of function computes and finds 96 bytes of memory is required. What is the value of this right now? 96 right now. Correct, right?
Yes, sir.
And this 96 you are passing here to malloc macro. So and that 96 gets copied to what? Middle argument was size of, yes or no? Hello?
Yes, sir.
So middle argument is size of operator. So now that 96 gets copied to yes, and T is your node. Okay, that is nothing but the struct list, and then P is the pointer to the struct list. Now what I'm saying, P is equal to, so malloc and yes, and yes is nothing but what? 96. So what malloc will do now? It will allocate so a continuous block of 96 bytes of memory. Correct, no?
Yes, sir.
So many bytes are allocated for you. Okay, and who will be pointing to that? P will be pointing. Hope you understood.
Yes, sir.
So in case in your main memory there is no sufficient memory, there is no 96 bytes of memory is not available. So then what malloc will do? It will return null. It will not go for allocating any memory. It returns you null. And I'm checking if P is equal to null. I'm saying printf, and this is not normal printf, fprintf, file printf it is. So whenever I write fprintf, you got to specify std error. Okay, std error is the standard error. So there are three things. One is standard output, standard input, and standard error. Okay, I'm just saying insufficient memory, and this standard error also prints the meaningful error message. So print this on where? std error. Again, std error is your monitor. So on the monitor, this insufficient memory gets printed, or otherwise you can just say printf. This std error is not required. You can just say insufficient memory. Okay, if you want to get, so this insufficient memory is what you are writing. Correct, right? So this is the message what you are writing. So but if you want to get along with your error message, the system generated error message also, then you can go for using fprintf, and you have to use the argument std error, standard error. Now it will display your error message. So insufficient memory, along with that it also displays an error message that is generated by the system. Hope you understood. Hello? So respond back. So I'm not getting any response today.
Understood.
Okay. See here. And then this is, see, the macro malloc starts from here and it ends here. Okay, and it ends here. So after this, so all the statements are under this macro right now, and just to show that these slashes are written here. Okay, now all these statements, so they are under this malloc. Okay, now, so I hope you people understood the malloc function. Correct, right?
Yes, sir.
Next.
Yes, sir.
Okay. So now what I'll do, I'll just go with the main function now. This is display. Okay. Let me start from the main. Okay. So here is the main. So this is what the Okay, so I am starting from the main. So int choice and done I'm defining. So node fi. Okay, so I'm taking one more pointer first fi is nothing but the first, and initially first I'm initializing it to null. Okay, and then done is equal to 0, so it was declared here and it is initialized here. Int n, and while not done. Okay, so n is for the number of students, n is for the number of students, and as usual, as we were doing in the previous programs, we have done while not done. Okay, so I'm just displaying this menu. So 1 for creating the list, singly linked list, and 2 for inserting at the front, and 3 for inserting at the rear, and 3 for inserting at the rear. So 4 for deleting from the front, and 5 for deleting from the rear end, 6 for displaying, and 7 for exit. So totally 7 options you have. So reading the choice here, and then say choice is 1. Okay, so we are creating the student. So it comes here. Now we have to say enter number of students. How many students are required? I am reading the number of students to n. Say for example 5 students data I need to read. So that is what is n is, number of students. And next, so fi is equal to create fi, because this first should always point to the first node. This I told when I was explaining you the concept of singly linked list. So first will be pointing to always the first node, and sometimes when we were discussing the concept of singly linked list, we took it as start. Okay, now here instead of start we are referring it as first. Now first is equal to create first I'm passing, so which is right now initialized to null, because my singly linked list is what, empty right now. And how many students data I need to create, or how many nodes I need to create? Say n number of nodes. I'm calling the function create. Hope you people understood till here.
Yes, sir.
Okay, see, so first pointer I'm passing because my list is empty. Singly linked list is right now empty. Null I'm passing, and how many nodes should be created I'm passing. Okay, and the return value from create I'm assigning it to fi. Finally, when create returns, fi will be pointing to the first node of the created singly linked list. Okay, now we'll go to create. So we'll go to the function create. Yeah, create here. Okay, create function definition is here, and I told create is returning what it returns. It returns a node. It returns the address of the node. Okay, now. So I'll just go to create again. So this is a lengthy program. You got to focus and understand. I'm passing fi. What is this fi? Fi is of type node, but right now its value is null. And what about this? This is an integer, number of nodes required. See, when I go to create, so now fi, I am just copying it to what? First. I've given the complete name here, first. Okay. Now what is the value of first right now? Tell me.
Null.
Null it is, and the number of students required gets copied to n. Now here I am taking a variable I, integer variable. Now I am checking if first is equal to null. Is that true?
Yes, sir.
Yes, because right now the list is what? Empty. The singly linked list, it is empty, nothing is there. Okay. And if first is not equal to null, so I come to the else part and print list already has some student data. Hope you are following. If first is not null, what does it mean? There is a list already existing. Okay, so I just say this. So list already has some student data. So now right now first is null. Okay, first is null. I enter into this. Now I run a for loop. For I is equal to 1, I less than or equal to n I plus plus. I go for reading the data. Okay, I just print enter the student 1 data. Okay, first student data I'm trying to read. So I just prompt this on the screen, and then immediately to read the first student data, I'm calling the function read data. Now when I say student data, so what are the information you have to read? You have to read the student USN, student name, student branch, student semester, and phone number. Okay, all these 5 fields you have to read. Okay, I just say enter student data 1, student 1 data or student data 1, it's no problem. And then read data function you are calling. We'll go to read data. In read data you will be reading, see here in the read data, see I am just prompting enter the student USN, reading the student USN to the variable USN, student name to S name, and student branch to branch variable. Okay, ampersand is not necessary here since they are declared as arrays, so the array name itself acts as the base address. And then reading the semester to sem and reading the phone number to phone. OP people understood? Now using read data function I'm reading all these things, and then after reading all those data, and again I come here. Okay, now I should go for creating the list by inserting at the front. Okay, all the data is read now. So USN is student USN is stored in the variable USN, name is stored in the variable S name, and branch is stored in the variable branch, and semester is stored in the variable sem, and is phone number is stored in the variable phone. Okay, now I'm calling insert front. I'm passing first is still null. Okay, now go to insert front function. So insert front function is here. Now the first what I'm copying, passing, again it gets copied to first, and the value of this is null again. Now I come here, I create one more pointer to my struct list with the name Q. Now I'm calling the macro malloc to allocate the memory. See, I have read right now USN, name, branch, semester, and phone number of a student. Now I need to store this into the memory location by creating a node. Now to create a node I'm calling malloc. Malloc I've already explained on the macro malloc I've already explained you. Q I'm passing, and then size of struct list node I'm passing. Okay, OP people are following?
Yes, sir.
So this, now once this malloc macro is called, so I'll just show you. Insert a table of 6 columns, and 1 row is sufficient. Let me take this down. Okay, yeah, insert front. Okay, observe now. So this malloc, what this function has done, it has created a node something like this. Okay, this is the node what just created, and who is pointing to this? Can you tell me? What is the name of the pointer that is pointing to this? This is one node right now. We have created the first node, and who is pointing to this?
Q.
Q. So you just observe here. Go to the malloc. I'll show you. See, malloc of S. We are assigning it to P. Okay, and then finally, when malloc returns, okay, you observe here, it is assigned to Q. Okay, so Q is the pointer. So now here I have written Q, and there I have taken it as P. Okay, so P and Q are same right now. Okay, now Q arrow USN is equal to USN. The USN which I have read here to this variable USN. From USN I am assigning it to this. Okay, say some USN 1, 2, 3, and then so from the variable S name I am copying the student name to Q arrow name. This is the USN field, this is the name field, this is the branch field, this is semester field, this is phone number field, and this is the link field which points to the next node which we create. Okay, so name gets copied here, XYZ, and then branch gets copied here, say CSE, and then the semester, third semester, and some phone number gets copied here. Okay, that is what we are doing. And observe now, q arrow link, okay, is equal to first. So what is first right now? You tell me, answer. What is the value of first?
Null, sir.
Null. So q, for this node, q is pointing right now. To this node, q is pointing, and this is the first node which you have created, and initially this link field should be what now? Null. So this should be made as null. Null. How we are doing it? So q is pointing to this. Using q, I'm accessing the link field. Q arrow link is equal to first, and first is null. Okay, so null is stored there. Now this is the first node which I've created now, and q is already pointing to this. Since this is the first node, I want to make first to point to this. What I'm doing now, first is equal to q. Okay, now to this node, so you have q also pointing, and first is also pointing to this. So these two are pointing to this. Understood now?
Yes, sir.
Yeah, and return first. What you are returning now? First. So first is what now? It is holding the address of this node, starting address of this node. Okay, and that is what we are returning. So I'm just returning from the insert front. Observe here. Where it is? Sorry. So it is in the create. Okay, insert front and first. Again, first is still pointing to what? The first node. Okay, next. So I go back. Okay, I is 2. Now I go for reading. Say for example, n value I have taken it as 2. Okay, so I is 2, 2 less than or equal to 2, true. Now I say enter the student 2 data. Okay, and then read data. Again I go here. Read data. So I read the student to USN, student to name, student to branch, semester, and then phone number. Everything is read and stored. And after that, so again I'm calling insert front, and I'm passing first. Okay, insert front, passing first. What is the status of first right now? Is it null or a non-null pointer?
Non-null pointer.
Non-null pointer, because first is already pointing to the node which we have created just now. Now we are going for inserting one more node to the front. Yes or no? We are calling insert front. We are creating a new node, and we are trying to insert at the front of the existing list. Okay, now let me go to insert front again. Yeah, insert front. So first is copied here. Observe node q, and again for one more node, again you got to create allocate the memory, right? Again I'm calling the macro malloc. I'm passing q, size of struct list, one more 96 bytes of memory is allocated. Okay, let me show that here by, or let me copy this and Control V. Okay, enough. See, this is the second node which I created, and it is empty. So all these things I have to remove. This is the second node which I have created. Now who is pointing to this? Can you tell me? Who is pointing to this node which I have created right now? Q. Q is pointing. Q was earlier pointing to this. The moment this new node is created, so Q is no longer pointing to this now. Only first is pointing to this, and Q is pointing to this right now. Q is pointing to this newly created node. Now what we do, the USN which is read and available in this lowercase USN gets copied to this USN field. Say 456, okay, 455, ABC is the name, and ECE is the branch, and say 5th semester, and some phone number. Okay, and observe now. Just observe here. So this is what I'm inserting now, and where I'm inserting this. This should be the first node now, correct, right? So all these things is done. Now this link field, what it should hold now? If I want to make this as the first node, this link field, what it should hold? Which address it should hold?
The first node address.
First node address, the address of the node with the USN 123. Yes or no? Now where do you find the address of this node? It is there in the variable or the pointer first. Now how to access this field now? So q arrow link, because q is pointing to this node, q arrow link is equal to first. Okay, so that means, say for example, address of this node, starting address of this node is 1000. So that is nothing but what? First value. Let me write here. Inside the bracket I'll write 1000. So value of first is how much? 1000. Say this is 500. Let me make it a 4 digit, 0500. I'll make it. Now this 1000, which is the address of this node, I have to store here. Okay. Now first I need to access this field to store this 1000 here. Now how to do that? So q arrow link. So I'm accessing this field is equal to first. First is nothing but what now? 1000. This 1000 gets assigned here. Is it clear? That means now you have a link from here to here. Let me draw that and show you. Insert. I'll just go to shapes. Okay. Let me take this. Oh, sorry. I think I have to take this. Oh, no. Multiple things. Okay, I'll take one more. One more. And the directed arrow. Correct? So from this node you can reach this node. And which one is the first node right now? Yeah? Which one is the first node?
USN 4551.
USN 455 is the first node now. So first is pointing to this. Now you have to make first to point to this. How to do it? First is equal to q. Okay. So first value was 1000. Now I'm making first value as 050 by assigning it with q. Okay. Now the moment this statement gets executed, first is equal to q. So first is not pointing to this, and the value of first is not 1000. So first, and it is 0500. So both q and first are pointing to this. OP people understood?
Yes, sir.
And return first. What is that you are returning now? 0500. This is the address which you are returning back. So let me go back. So I told only 2 student data, because 3 again it will be continuing with the same thing. Okay. So I'll not go enough. 2 things are enough. Okay. I hope you understood how to do the insertion at the front and create the student list. Correct, no?
Yes, sir.
Okay. So that is what in the case 1. Okay. So enter the number of students for every student by calling this create and by passing fi. Fi is nothing but the first. Initially we are making it as null. Done. Next. Case 2. Say insert at the front. Okay. This is for creating. I am creating the singly linked list by doing insertion at the front. Okay. Now insert at the front. Again the same thing. So I want to add one more student data. Okay. At the front. So again case 2, I come here. So now I am not going to read the number of students because the list is already there. Now to that list I need to insert the new student data at the beginning or at the front. So I just call read data, which is already explained to you. So there we read the USN to the variable USN, name to the variable SName, and branch to the variable branch, and semester to the variable sem, and phone number to the variable PH number. Okay, we read it. And next again I call insert front. Okay, now I don't call create now. So create function I call when I am creating the singly linked list for the first time. Now, so the list is already there. I have the list with 2 nodes already present. So list with 2 nodes is already there. Now I just want to insert the data of one more student at the beginning. So I just call insert front. I'm passing n, only this what fi. Okay, now we'll go to the insert front. Same thing what we understood. Insert front. So create the new node. So one more node gets created. Assign the USN, name, brand, sem, all these things. Now what you do? So to the link field of the newly created node, assign the address where first is pointing. Okay. So one more node will be there, and now to the link field of that node, what does that have to store? 0500. OP people are able to imagine.
Yes, sir.
And then you got to make the newly created node as the first node. How do you make it? First is equal to q. See, when you are writing even in the program without saying, see, you got to write these things first. Okay, the pictorial representation you have to write. Mentally you got to recall the logic, and same way you can write the program. See, if you're not doing this part, if you're not writing, say it's left side, you got to put a margin and you have to write all these things. Only when you write, you can clearly write the program. Otherwise, you'll get confused. Okay. Now first is equal to q. So first points to the first node and return first. And there's nothing difficult in the case 2. It is easy since you already know how to do insert at the front. Next, case 3. Insert at the rear. Okay. So now again I come here to 3, and again to insert at the rear also I require the data. I'm calling read data, reading the data of the student, and now instead of insert front I'm calling insert rear. Okay, people are following? Insert rear, I'm passing first again. I go to insert rear now. This is read data, this is create, this is insert front. Now insert rear. Okay, in insert rear also. So I am creating a new pointer q. So what is q now? Q acts as a pointer to the struct list, and first is just assume this is my existing list. First is pointing to this node. So and t is equal to first. What will happen? Where t will point? See, first is this node, correct, right? I am saying t is equal to first. Where t will point now? To which node t points? When I say t is equal to first. Am I audible?
455.
Yeah, 455. Even t also points to the node to which first is pointing, correct? No, t, and its address is also 0500. Okay. Now why I have taken t? Because I need to move till the end now. Because insertion in new node, I have to insert at the rear end of my list. Correct? No. From the from the starting node, I have to keep traveling until I reach the last node. And for that traveling purpose, I have taken one more pointer with the t. Because first I should not disturb. Because first should always point to the first node. So I have taken one more pointer t, and I have made that pointer t also to point to the first node. Next, okay, you got to create a memory. Correct, right? Allocate the memory. So I'm allocating. So I'll just do copy of this. So since the one more node I have to insert here, correct? No, I'll just paste it here. This is not required. See, all these things are empty. See, I have created this node. Okay, a new node is created, and who is pointing to this new node? So just look into this and tell me. Q is pointing. So Q was earlier pointing to this, now Q is no longer pointing to this, and Q is pointing to this. Q. So let me take this address, this node address, I've called it as 1000. Now this node address, let me call it as 2000. So Q is pointing to this node right now, the one node which is created. And is this node already linked with this node? It is not yet linked. We have just created the node, and we know the address of that node, that's all. Okay, and Q is holding address of that node right now. And now I go for assigning the USN. Q arrow USN. So this node is accessed, and I store here, say 111, and then some PQR, and then branch, mechanical, and then semester 7, and then some phone number, and now observe now. So all this is fine till here. Yes or no? So sorry, not this is the front function. Insert front function. Insert front. Now we have to look here in the insert rear. Next. So all these things is fine. Okay, assigned USN, assigned name, assigned the branch, semester, phone number, everything I've done. Now since this is the last node now, we are inserting at the rear end. What is that you got to store here? What you got to store in the linked field of this last node which we have created?
Null.
Null. So how to do that? Look here. Q arrow link is equal to null. Is that fine?
Yes, sir.
Yeah. So I am storing null here. Done. Next. Look here. If not first. Okay. So see, if the list is empty, okay, what you are doing? So if not first, okay, so if first is already null, what you are doing? You are making first is equal to Q. This node will be made as what? The first node. Yes or no? And we want first to point to this. Is it clear? People of, so assume this list was not there. This list was not there. What we have created itself is the first node. Hope you people are following?
Yes, sir.
Yeah, that time what is that you have to do? First is equal to Q. I am checking here. If not first, okay. If first is null, okay, or if not first, what we are doing? First is equal to Q. So right now this condition is not true for me because first is not null. It is pointing to this node. That means the list already exists. Now I have to go to the else part. Now here what I do, while T arrow link, see I am already made T also to point to the first node of my existing list. T is already pointing to this. Okay. Now what I do, so make T arrow link. T is equal to T. So T arrow link. T arrow link is what now? 1000. Yes or no? Now any non-zero value is considered as what? True or false? See, T arrow link. So T is pointing to which node? This node. Yes or no?
Yes, sir.
T. If I ask you what is the value of T, you'll just say it as 0500. If I ask you what is T arrow link, how much it is?
1000.
1000. While 1000, is it true or false? So now T arrow link value is how much? 1000. While 1000, is it true or false?
True.
True. How do you say it is true?
T arrow link value is 1000.
Yes, T arrow link value is 1000. The non-zero value, you will consider it as what? True. Yes or no?
Yes, sir.
Yeah. While true, this statement gets executed. What is that? T is equal to T arrow link. What was the value of T? 0500. Now you are making T is equal to T arrow link. So this is 1000 now. T is equal to 1000. Now what happens? So T is not pointing to this right now. So we have made T to point to the next node here. T is pointing to this and its value is 1000. So T is right now pointing to this node. Earlier it was pointing to this. By doing T is equal to T arrow link, I made T to point to this. Is that clear?
Yes, sir.
Okay, now come here. Again it comes to the while loop. Now T arrow link. So T is pointing to this node and T arrow link is this. How much is, what is its value as?
Null.
Null. See? Now while null, what it will do? It will come out of the loop. So it comes out of this, and that means we have reached the last node. So this is the last node now. And this is the new node which is created, which is not yet connected to this. Okay? Now I use this T in order to travel and reach the last node. When T arrow link is null, I have reached the last node, come out and see T arrow link. So T arrow link is this field. What is that I have to store here? Tell me. This null I have to remove and I have to store 2000 I have to store. Now where is that 2000? 2000 is the value of Q. So same thing what we are doing here. T arrow link is equal to Q. So this is removed and we are storing 2000. What does it mean now? Now from this node I can reach this. Okay. Let me copy this. It is something like this now. So from this you can reach this, and null we have already stored here, and first is still pointing to this. OP people understood? Okay, see, T is equal to T arrow link is equal to Q and return first. So first is still pointing to this. So have we inserted at the rear end? So are we successful in inserting the node at the rear end of the list?
Yes, sir.
OP people are following. See, once you understand, everything looks so simple. Okay, the only thing is you need to get the start. So to get the start, all these basics you have to understand. So once this is clear, so you can go for inserting or deleting from any end. Okay. So I think it is already 4. Okay. Insert rear I have finished. Still we got to discuss delete front, delete rear, and then display. Okay. So these things we'll discuss in the next class. So please do remember till here. Okay. So at home, say I'll be sharing this program to you people. So sit yourself. Okay. Take a piece of paper. Try to write and trace it down. You'll understand everything clearly. Okay. So can you people say with confidence, sir, we have understood? So I want to hear how many of you will say confidently, sir, we have understood. Hello?
Understood, sir.
Only one girl told. So out of class strength of 64, only one boy. Out of 64, one boy and one girl. What about the remaining people? Are people listening to me or just connected and sleeping? Yes?
Understood, sir.
Understood, okay. So it's not at all difficult if you understand it, okay? So it's very easy. So in case if you have any doubts, just go through it. So I'll upload today this program to my Google site. Go through it. So when you're trying to analyze it by yourself independently, so you'll learn many things, okay? And during that time, if you get any doubts and if you need further clarifications, make a note of it, and tomorrow when I come to the class you can ask me, I'll clarify, okay? Now we will stop here, okay, and we will continue in the next class. I think I have to save this file because I've written all these things, and in the next class I can continue from here itself. Let me save this.
Excuse me, sir.
Yes, ma'am.
Sir, can you upload the remaining videos on YouTube, sir? Because we have lab internals next week.
Yeah, I've uploaded around 35 videos.
Yes, sir. I think
Yeah.
it's still queues or something, sir. Even we want linked lists also, sir.
Okay, I think I have around 45 videos still now. Remaining 10 more I have to upload. I'll upload it today.
Okay, thank you, sir.
Okay. So just be there until I finish taking